Alright, welcome to lesson 4, subtracting polynomials. So the last couple days we've been using algebra tiles to add polynomials. So if you're adding polynomials, you just group them together and count up how much you have. So to start off in class, we kind of talked about this concept of if you have 3 minus 5, that equals negative 2. And if you have 3 plus a negative 5, that's also negative 2. And you can go through any number of examples like this. 6 minus 5 is 1. 6 plus a negative 5 is still 1. 3 minus 3 is 0. 3 plus a negative 3 is 0. So what we can see here is subtracting is the same as adding the opposite, right? And we also have to go over this concept that y plus 6 here in brackets is not the same as negative y plus 6, okay? The negative actually gets what's called as distributed to everything that's inside the brackets. Now when we're dealing with algebra tiles, adding the opposite with the algebra tiles is basically flipping the second set of tiles. So if we're taking polynomial a, which we're going to call these positive, the unshaded ones, and negative are going to be the shaded ones. So this first set of polynomials, we have 2x squared plus 3x plus 5. And the second set of polynomials, which we are subtracting, is negative x squared minus x minus 2. So if we go back to this initial idea that subtracting a number is the same as adding its opposite, if we take that concept to algebra tiles, adding the opposite is going to be flipping the algebra tiles. So if we were to flip all these over, you would end up with that. So polynomial a minus polynomial b is actually the same as polynomial a plus the opposite of the set of polynomial b. So if we draw out our initial set of polynomial or of algebra tiles, and we add to it our newly flipped set of algebra tiles, what's our total? Well, we have 3x squared plus 4x plus 7. And let's go do the symbolic representation of this. So if we are subtracting this set, we're going to distribute this negative to all parts. So polynomial a stays the same. We haven't done anything with it. 2x squared plus 3x plus 5. The second set of polynomials here, however, because we're distributing this negative, that becomes plus x squared. The second term becomes plus x, and the last term becomes plus 2. Well, if we combine those, 2x squared plus x squared is 3x squared. 3x plus another x is plus 4x. And 5 plus 2 gives us plus 7, positive 7. And you can see that whether we do it with the algebra tiles or whether we do it symbolically, we get the same thing. So removing brackets, also known as distributing the negative. So if we want to get rid of this set of brackets, you need to multiply the negative by each term that's in there. So this becomes negative 2x minus 3. If you were to think of that in terms of algebra tiles, you would originally have 2x plus 3, and we're flipping them over to show the other side. And all the tiles have to be flipped, so all the terms in the brackets change sign. So this negative makes that negative 2x, and the negative times the negative 3 becomes positive 3. Negative times a negative becomes positive 2x, And negative times a positive becomes negative 3. And the last one here becomes positive 2x and positive 3. So everything changes sign when you distribute the negative. So let's put it all together here. The first set of brackets does not change. The second set changes sign. So it was positive n, now it's become negative n. It was positive 5, now it's negative 5. And then we collect like terms. 3n minus n is 2n, and 7 minus 5 leaves us with positive 2. 8t plus 9 is unchanged. The negative makes that negative 6t, and the negative makes that positive 1. Combining like terms, we're left with 2t, and 9 plus 1 gives us 10. Here the first set, or the first bracket, remains unchanged. This negative makes that positive 5x, and makes that negative 2. And if we combine like terms, we have 6x, negative 3 minus 2 more, gives us negative 5. Here we have 3 terms in our first set of brackets. That part still stays the same. This negative gets distributed. That becomes positive 4m, and that becomes positive 12. Now we have to collect like terms. So pause the video, underline what you think you would collect, and then click play. So hopefully you've done this. M squared. There's nothing else to combine with it. There's no other squares to combine. The negative 2m and positive 4m are going to leave you with positive 2m. And the negative 3 and the positive 12 give you positive 9 remaining. Here's kind of a word problem, and we're told the entire perimeter here is 10r plus 12. So if we're to draw that out, 10r plus 12, that is a lot of drawing, but it's going to be useful. 10r means that we just have rectangles, not the squares. So we have 10r, and then we have 12 units, single units. Now, what we're going to do here is we're actually going to dedicate some of these to each side. Now, we're already told that this is 4r plus 4. So these 4 and those 4 are accounted for. They represent that side. Well, if this side is 4r plus 4, this side must also be 4r plus 4. So another 4r and another 4 are dedicated to that side. So that leaves us with 2r plus 4 for these two sides. Well, we have to do them evenly. So if we take this r and put it on this side, and we take this r value and put it there, those are now accounted for. We have to distribute these 4. So 2 go here, and 2 go here. And we've accounted for all our r's, the rectangles, and we've accounted for all our 1s. If you count them up, we have a total of 10r plus 12, and they're all representing the perimeter. So the width, in fact, is r plus 2. Here we've got multivariable polynomials. So the first set, just like before, stays the same. Let's get a smaller pen size here. So 7x squared plus x plus 2xy plus 3y minus y squared. We don't actually need this set of brackets here. Now this part, this negative is actually going to get distributed. So that becomes positive 4y squared. That becomes negative 3y. That becomes positive 3xy. That one's negative 5x. And that one's positive x squared. So here's where you need to pause the video, take out your highlighter, and group like terms. So the first ones we got to group are the 7x squared and the x squared, and that's going to give us 8x squared. The second set of things that we need to group are the positive x, and looks like negative 5x. So positive x minus 5x is negative 4x. Then we're going to go ahead and combine the 2xy and the 3xy. And that gives us 5xy. And then we've got the 3y minus 3y. Well, 3y minus 3y is 0. So we actually don't have to do anything there. It just cancels out. It's a 0 pair. Then we've got y squared and 4y squared. So negative 4y squared plus 4y squared leaves us with positive 3y squared. There's nothing else to combine. There's no more like terms, so that's it. So on your own, try these, pause the video, and then check back for answers. So this one, if you distribute this negative, we get x squared plus 5x minus 7. This becomes positive 2x, and that becomes negative 3. Combining like terms, we get x squared plus 7x minus 10. Here, the first set of brackets stays the same. This negative becomes negative x squared. That becomes negative 3x, and that becomes positive 5. Combining like terms, 3x squared minus x squared gives us 2x squared. Negative 4x and negative 3x gives us negative 7x. And positive 3 and positive 5 gives us positive 8. Here, the first set of brackets remains the same. That becomes positive x squared. That becomes negative x. And that becomes positive 3. Combining like terms, we get negative x squared plus 3x minus 2. And our last one here, the first set of brackets, remains unchanged. If we distribute this negative, we get negative 2x squared minus 2x minus 5. And combining like terms, 5x squared minus 2x squared gives us 3x squared. Negative 7x minus 2 more is negative 9x. Positive 4 minus 5 leaves us with negative 1. There you go. We're actually going to skip this first PAT question and move on to the second one here, number 26. So we have to simplify this, which means distribute this negative. So the first set of brackets remains unchanged. Distribute that negative. It was positive 3x squared. Now it's going to be negative 3x squared. That becomes negative 8x. And one more, negative 20, if we're multiplying it by a negative, becomes positive 20. So go through, highlight your like terms. X squared minus 3x squared is negative 2x squared. Negative 5x minus 8x is negative 13x. And positive 4 and positive 24 and positive 20 give us positive 24. And that's option A. Another example here, when x squared minus 9x minus 4 is subtracted from the sum of 5x squared and this next set of polynomials. So the sum means to add. So we're actually got to add these two here. Now, adding polynomials, you don't need to distribute a negative. You just collect your like terms. So 5x squared plus 2x squared is 7x squared. Negative 8x minus 3 more is negative 11x. And positive 2 minus 7 is negative 5. So we've successfully added these two. Now the rest of the question asks us to subtract this polynomial from it. So this means that we are subtracting the entire thing. Well, here's a negative, which needs to be distributed. So 7x squared minus 11x minus 5. That becomes a negative x squared. That becomes positive 9x. And that becomes positive 4. Now we collect like terms again. 7x squared minus x squared becomes 6x squared. You'll notice there's only one option with 6x squared, but let's just go ahead and finish off collecting like terms. Negative 11x, positive 9x leaves us with negative 2x. And negative 5 and positive 4 leaves us with negative 1. And guess what? Everything else matches up. So we're into classwork. The classwork is included in the class notes, page 26, 27, and 28.